the event described me as a cloud evangelist, but they wouldn't let me use the real title, which I tried, was cloud extremist. I have been kind of using the cloud for a very long time, since about 2006, and done some quite leading edge stuff, I suppose, for quite a long time. But I take a network point of view of the cloud. So it's a different point of view from the familiar one, especially nowadays. And when I wanted to do the title for this talk, I kind of Freudian slipped and dropped out the X. So cloud, what comes next, really describes what I want to say, as you'll see. So when that's me, actually, a long time ago, when I started off 35, nearly 40 years ago, as a network engineer. I've got a network background, you see. That's what sort of informs my view of the cloud. So a very long time ago, I had even more hair. And back then, the cloud, it was this thing which connected networks together, really. We didn't know what was in it. We didn't have services as such. It was just this thing which we used to route between networks. And I came to really understand what we mean by that, the Thunderbolt symbol that we use in network diagrams to connect wide area networks, because sometimes, way back then, before we had kind of filtering on, you come in after a thunderstorm at night and find some of your equipment blown out. So yeah, I really did understand what that symbol came to mean. So today, though, what we usually see when we look at the cloud are these big companies. I was describing a question earlier about, this gravitational effect that these companies are getting bigger and bigger. There's a reason I chose these 5, as you'll see later. But what I want to say is that the cloud's getting on a bit now. It really is mature. Everybody's kind of heard about it. Not everybody's moved, but they're all aware of it. I'm sure if I was a Martian coming to Earth today, I would say, why on earth would you build on premise? That's only because of legacy. But the cloud has got a long legacy. It's got deep roots. Now, this was the first computer I programmed back in the mid-70s, really. ICL 29,000, 2900 rather. 15 million pounds in today's money for 8 megabytes of RAM. Quite extraordinary. But this was in the University of Kent, and all the colleges, schools in Kent would connect to this in some way. Later on, I programmed machines at the University of London Computer Centre. Same scenario. You had terminals that would connect to a big shared data centre, or mainframe back then. No wonder that Watson, back in the 40s, really said that the world only needs 5 big computers. At that sort of price, you couldn't really afford, what we have today. Then you went through various steps of shared computing, time sharing, and so forth. And probably about 1966, Parkhill really nailed the cloud with a mainframe view way back then. Kind of like Amazon's elastic compute service. You time sharing, you use as much as you want, you pay for what you want, it can do applications, it can do data. He kind of nailed it way back then. And then, of course, I'm sure you've all heard Nick Carr's book by now, The Big Switch. But he kind of reheated Parkhill's analysis way back into the contemporary era. And he kind of modeled it on power grids. You don't have, apart from your backup, you don't really have generators in every building. You do for your on-premise data center, of course. But and then when you look at these, the amount of power that these big data centers consume, really makes them like huge power stations. But you just, with the cloud, you connect into a grid just like electricity. And of course, even the tinsy-wincy machine can command great power. From your mobile, you can rock up, instances of Amazon Web Services. You can connect to the data centers, and you can, from your little mobile, you can compute on scale. It's quite extraordinary. But in a sense, it all depends on your point of view. So I'm just running through some of the history here in a sense quickly. But again, 2008, same time as Carl wrote his book, Zitran kind of warned about the fork of the internet. the original internet, as I used it as a network manager way back, was to connect networks together, to connect things together, not to connect you to big companies necessarily. And he warned about this fork between, the gravitational pull of Google, Amazon, Microsoft, etc., into these kind of like what people call closed walled gardens. You see it today, like Amazon won't sell Apple's stream service, or Google won't sell something else, They are kind of protecting their own interests in a sense. Versus the generative net, he described it as the original intention of the internet as a kind of free and open resource. And then 2011, when Google met WikiLeaks, Assange met Schmidt, kind of demonstrating the poles apart, where Schmidt is talking about connecting companies to connecting markets to American companies. With the Loon project, for example, we are saturated at the moment in the West. So where Africa, the developing countries, like Facebook, create new markets by floating balloons or having solar-powered drones to give them the internet to provide a bigger market space. Versus Assange, really, which is talking about freedom. Again, it's the same forking of the internet. It's commercial interests versus kind of social, cultural interests. And then the reason I used those 5 companies in particular is because in 2012, Bruce Sterling kind of warned about where we shouldn't really talk about the internet anymore. We've just got these huge companies that are trying to recreate the world in their own image. And then 2013, Edward Snowden on Big Brother and the dark side of the moon, if you like, state surveillance using, it couldn't be better, could you? George Orwell, the cloud and so on didn't exist in Orwell's 1984, when he wrote 1984. He couldn't have imagined it, the opportunity for the state to get under the covers and see what you're doing, dragnet, mass surveillance, extraordinary. And then Tim Berners-Lee, looking very serious and angry about what's happening about his web, if you like, what's happening to the internet and the web, how it threatens the future. Oh. Okay, and then at that time, the time was ready because, young kids had got fed up with Facebook anyway. You put all your drunken photos up on Facebook, everybody can see them. They'd all moved on in a sense, or moving on, because Facebook, even back a few years ago, was for old people. They've shifted on. So the market was ready, but all the state surveillance, all the privacy concerns, out came a slew of encrypted, ephemeral messaging apps. Private, we don't want the state to see this. We don't want our mums and dads to see it. We message amongst ourselves. So you've got all these encrypted applications that came out, and it's carried on today with likes of Bleep or Signal, which Edward Snowden says he uses every day. And by the way, I know you know. Silent Circle, the famous black phone, got the silent phone app that you can get. Government people would use silent phone, in fact, to keep. In fact, the way back was about a year ago, it's 9 months, when the Americans were found to be snooping on French ministers' phones, for example. Maybe they should use the black phone. And of course, there's Telegram. I can't remember the guy's name, but he's described as the Russian Mark Zuckerberg. The story goes that he developed Telegram so that he could carry out his business without Russian surveillance. And it's a very, very useful application. Does all this stuff. At the center of it, of course, is encryption, privacy, security. But it does all this other stuff, connect, coordinate, synchronize, etc. Great private security tool. But of course, recent events have shown that that very thing can be turned on the other side, and the Paris attacks were said to be coordinated through the same application, Telegram, to such an extent that the security community were blaming Snowden for creating the kind of climate and the applications and the technology which the terrorists were using to attack us. kind of hypocrisy, I'm not sure there, but it was the state surveillance, which caused Snowden to leak out, if you like, and expose all this. Anyway, the point I want to make is that the internet's an old model. It was based in a different era, back in the early 70s, like that mainframe that I used. It was designed to connect people to big immobile computers. And there weren't meant to be that many of them. We ran out of IP version 4 just about, I think last year actually, run out of new addresses, or they're really running dry, aren't they? I don't know how many people have moved to IP6 yet. I'm hoping that I would be maybe long gone by the time I have to sort of sort that out. But it's creeping along slowly, and the infrastructure's got it. But it was a different era. Today, of course, it's very different. We've got, well, not millions, we've got billions of mobile computers. They're not stationary room-sized anymore. They're in your pocket. And tomorrow, of course, it's going to be in your hand, on your wrist, on your eyes, and Internet of Things everywhere, just immersive computing in a sense. And of course, your mobile phone has got more compute power than got us to the moon in 1969. It's got more compute power than I used on that £15 million mainframe way back when I was a young man. And the other trend is that, interestingly enough, in a sense, each generation of computing has pretty much, like Moore's law almost, 10 times the number of devices as the previous version. It's a typical trend in IT. Things get cheaper and they get smaller and they get more in number. So, maybe 1 million mainframes, but might have 10 billion mobiles now. But coming is the Internet of Things and wearables, where you're likely to have, maybe 100 billion devices on the planet, in addition to the mobiles and the laptops and PCs and the mainframes and all the rest of it. It's quite extraordinary. There's going to be a lot of stuff, basically. And you've got a generation of people that have grown up, cut their teeth on a different form of computing than we used here, like I used. They haven't necessarily, millennials haven't necessarily used a PC first. They've come up and they've used a tablet or a smartphone first. I've seen it at schools, colleges, they've got to sit down and adjust to using a keyboard, mouse, I want to use my finger. So here comes everybody. It's part of what I want to say, in a sense, these sort of nice little catchphrases of books. The opportunity's there for everybody. Everybody's got a computer, a supercomputer in their pocket. But the problem is, of course, when we think about the future, we're often constrained. We're often constrained by what has gone before, the thinking that we're in at the moment. And that Byte magazine cover kind of illustrates this way of thinking. I remember having a little watch way back, well, maybe it's the 80s, I don't know, with a little keyboard thing on it as a calculator, trying to press those buttons was ridiculous. People were still in that mode of thinking. They weren't and this is the nice thing about wearables at the moment. They are being thrown up for design challenges. You don't necessarily want to use either keyboard type thing. You want to use gestures, so you've got to read this, you've got to think completely different. Think outside that box completely. So basically the cloud really, in a sense, is just an old model. It's the old mainframe model. I'm not surprised that people have such trouble with it. Way back we had time-share computers, and organizations would connect to those time-share computers. Then you got the PC revolution, really, but people as old as me remember, so the cloud for me, for my generation, was nothing new, really. It was just old hat. That's why I took to it. That's probably why I'm a cloud evangelist, because I thought, whoa, it's just like my youth. I recognize this model. It's easy. So, yeah, generally when people look at the cloud, they see, these big type of companies, maybe gravitational effects, as I said, would suck everything into these great big, I won't say black holes, but these great big organizations eventually, with the layers on top, cloud providers, building services on these maybe. But when I look at the cloud, I see networks, I see people. Berners-Lee, in his original descriptions of the web, described it as a means of connecting people, not really computers. And I see things, these billions of things that we're going to have in the world. And again, instead of big data centers, I see a swarm of things. And so people are working on reinventing the internet. Now, the internet's going to disappear. There's likely to be a parallel system built somehow. We don't change. One thing you can't predict is the future, really. So you've got Cambridge, you've got Xerox. I remember Xerox. Working on, instead of location-based access, ways of finding information based on content or the information that you want to find. And the swarm protocols are so effective when they actually get better with numbers. This is an extraordinary thing. I was trying to think of, was it last Christmas or the Christmas before when Sony's been hacked several times, haven't they? So many times. But I think one of their first hacks was when they tried to show a film. It was controversial. There were threats to the cinemas. Sony was taken off. I think BitTorrent sites, they offered to host it. I think YouTube hosted it online at the time. Google having that kind of scale. But the other organisation, the torrent organisations, they can counter DDoS, denial of service attacks, because they usually come from botnets. What better way to face up against botnets than another swarm against swarm. You've got this different approach. You've got all your eggs in one basket, one big fortress, and you've got all these things hitting it. Just fry your on-premise kind of resource, your firewall, your router, unless you wash it through the cloud with something like Red Spam or something like that. You have a cloud filter. But there is another approach, a bit like the human brain. We're not really that centralized. The neocortex is distributed and decentralized to a large extent. Redundancy, we talk about redundant, anyway, I won't go on to that, I could go on to, that's my subject, that's my background actually, psychology and anthropology, but the redundancy in the brain is largely due to the decentralization. But there is a model you may be familiar with. I grew up quite familiar with this. Grid computing. It is a swarm, but it's like with Queen Bee. You've got a control. It's just like the botnets. You've got a control. But our college, with 5,000 PCs, a quick calculation of the PCs, if they were used in the whole grid, they give 100 teraflops of compute power and a petabyte of storage. Rather than having a data center, you just use all those machines out there. Don't have a data center, just use the distributed machines on your network. And we use them for good causes, to do SETI, search for extraterrestrial life, cancer research using the BOINC. You can use your mobile phone, Google Play, the BOINC network. I can't remember what it stands for, Berkeley Open Network Computing or something like that. So that's one approach that's almost hybrid. You've got central control and you've got distributed machines. But enter the blockchain. There is a completely decentralized. Anybody heard of the blockchain? Ah, cool. Actually, that's a lot more than I imagined, actually. There's a well-informed audience here. So this is a different approach. A blockchain, a distributed, decentralized model. Turn the cloud inside out. I like that. I really like that phrase, And you've got all these industry leaders, haven't you? The thinkers there, like Tim O'Reilly, described it as a new platform. The Tapscott's got a book out in May on the blockchain. They were speaking at Ethereum conference last week, I think it was. And of course, Mark Andreessen, you may know, is an angel investor, talking about how it's early days at the moment for the blockchain. It's just like PCs back in 1975 or 1976 when Apple I came out. Not necessarily quite up with his timings there, but with these sort of things, they're difficult to predict. You've got an exponential curve. So it's very early days for the blockchain, but there's so many people, so many organizations, and so many smart people having a look at it that it's quite, it looks like it's got some traction in there. People working on blockchain application stacks. Just familiar sort of stuff, but underneath it, you know, you've got, a Bitcoin blockchain or other types of blockchain. And you've got smart guys, smart young things, a bit like Bill Gates. If you've ever heard this, I was watching a video of him talk. He is unfortunately, you know, the archetypal geek, teenager. I think he was 19 when he started this project. So he looked at Bitcoin, you know, which is kind of quite revolutionary, hideously complex in a sense. So I can do better than that. And so kind of redesigned Bitcoin for Ethereum. And they're still using blockchain, but they're using a different protocol instead of Bitcoin. And people have described this as the way the internet was supposed to be, rather than, you know, like a terminals to major data centers, a network of networks, a network of things to connect stuff up. And you've got people, you know, decentralize everything. You know, but this is the extremist side, you know. It just depends on your psychology. And some people really quite like this anarchic approach to it. In fact, I've been described as an IT anarchist as well as an extremist as well. But something about this appeals to me. Of course, you've got you know, the financial markets looking at blockchain quite predictably, really, UBS. IBM, now, the link up with the Internet of Things is no coincidence, is it really? 1 minute, I'm almost there. IBM using distributed network to control distributed network of things. Microsoft are in there. I've got a couple of slides there. Microsoft in there with blockchain as a service. Click the button out of their cloud service and deploy to the blockchain. You've got governments looking at it. You've got people wanting governments to look at it because it makes transactions and regulations transparent and immutable. Once it's in the blockchain, you can't change it. You've got bright young things wanting to go the step further and to decentralize and distribute organizations. Always reminds me of that film Elysium, where they've got an algorithm running the space station in a way. And of course, it fits in very nicely with a set of robots, AI. If you can get a distributed organization on the blockchain, you don't know whether you're talking to a human or a robot. You don't know whether your CEO is a robot or a human. The organization is algorithmically controlled. A lot of people say that on other things, work I've done, that research people prefer working for robots than for people. For certain reasons, but I won't go into that now, obviously no time. And so, last slide pretty much, when we go driverless, when our organizations and the way we work changes, you know, what will we do? We'll be freed up to do something else, but like driverless cars, you know, these are coming, possibly blockchain's going to be on the same curve as driverless cars. People are saying 2020, it's going to be commonplace. 2025, it'll be almost the de facto. You know, by 2020, you know, people will be, the technology will be built into the cars, and we'll be, 10 years from now, we will accept it, they'll be everywhere. So, last slide, just leave you with, you know, the typical, you know, I like this one, it's very, very pertinent to the blockchain, the decentralization. You know, the future is already here, it's not evenly distributed. It's kind of like in blobs at the moment in the cloud, but you know, maybe it will be distributed better. And then, of course, if you think it's stupid, you know, the Arthur C. Clarke's quote at the bottom there is, well, you're probably wrong, maybe. You know, the future can be very different from the past. So thank you. All right.